In this video, we're going to talk about the difference between simple interest and compound interest. For sake of argument, we're going to go ahead and borrow $100, and we're going to see what happens after a time of 1 year. Well, for the first case, we're going to have simple interest here, and let's say our annual rate is 8%. So by our formula that we had before, the amount you owe at the end of the year is P times 1 plus RT. That's $100 times 1 plus 0.08 times 1. And so at the end of the year, we would owe $108 even. For our counter example, we are going to use compound interest. Also going to have an APR of 8%. And we are going to compound 4 times a year. So we can plug it into the other formula for compound interest, P times 1 plus R over N to the NT. That's 100 times 1 plus 0.08 over 4 to the 4 times 1. And we get $108.24. So you see, by having the compound interest, we ended up owing greater amount at the end of the 1 year. In this case, it's about a quarter that we owed more extra, but it is still more. And if you owed larger amounts, say you're buying a car or a house, it ends up adding quite a bit over the life of the loan. Now, since it does count for more, so 8% compound is not the same as 8% simple. It is some more amount. We'd like to figure out how much more it is. So let's just give another example here. Let's suppose instead that we had a simple interest here that was an APR of 10%. Then if we use the formula again, we would get the following here. We'd get $110 at the end of the year, which is more than what we had with both the simple 8% and the compound 8%. So what we have here is that the compound 8% is worth more than 8% simple, but not worth as much as 10% simple. We would like to figure out exactly how much it is worth comparatively. Well, in this case, we have a nice way we can do this. We can use our algebra skills. So the idea is we have an amount from simple interest is P times 1 plus RT, and we have an amount from compound interest, P times 1 plus R over N to the NT. Now once again, we're always going to look at what happens with only 1 year. So our T is going to be 1 in both cases. We don't really need that. But the really important idea here is that we want to know how much is that compound worth? What is the equivalent annual rate for simple interest? For equivalent means we're going to set them equal to each other. So we set the simple formula equal to the compound formula, so that we're saying they get the same answer. Again, I'm going to plug in my t equals 1 here, so that's just going to go away. So I'm going to erase that here. Now that we've got our formulas here, notice something else happens. Our p is going to cancel out, and we get the following then. 1 plus r equals 1 plus r over n to the n. Now I do want to point out something here. This is kind of bad of me. The r on both sides of the equation are actually different values. One is the r for simple interest on the left-hand side. The other is r for the compound interest. And it's a really bad thing to use the same letter in both cases, but the formulas that we started with had them, and we just need to be careful here. So what we're going to do is we're going to then solve. We get the following here. 1 plus r over n to the n minus 1. And this would tell you what the simple interest you need for an equivalent compound interest of r%. And what we do is we actually call this APY. So you're going to have the following formula you can use. APY is 1 plus r over n to the n minus 1. And APY, it stands for annual percentage yield. And so what that means is that is what percent you actually gained or lost total at the end of the year. And this formula here will allow you to get the answer for any of those problems that is asking you to compare compound with simple.